Hi, Assalamualaikum and good day. Today we are going to learn chapter 3 that is on differentials and related rates. Following are the outlines of chapter 3. Under this chapter, you will learn about differentials, related rates, analysis on functions, maximum and minimum values, and apply maximum and minimum problem. These are the objectives of today's lesson. Hopefully, by the end of this session, you should be able to find the approximate value of a function using differentials and solve problems involving related rates. In calculus, a differential is referred to the change in the function with respect to change in the dependent variable. For example, if given y equal to fx, then dy over dx is equal to f prime x, in which dy can be written as f prime x dx. Here, f prime x is the derivative of f with respect to x, and dy dx are the differentials. The differential can be used to estimate or approximate value of a function y caused by a small change in x. Let's say the small change in x denoted by delta x and the small change in y denoted by delta y. If delta x equal to dx and delta y equal to dy, as dy is equal to f prime x dx, then delta y can be written as f prime x delta x. Thus, to find the approximating value of a function caused by a small change in x, this is the formula to be used. Following are the steps to find the approximate value of a function. First, determine the fx if it is not given. Next, find the suitable value of x0 and delta x. Here, x is equal to x0 plus delta x. Then, differentiate the fx and calculate fx0 and f prime x0. Finally, substitute all related values into the formula. Now, let's refer to example 1a. You need to estimate the value of square root 25.01 up to 3 decimal places using differentials. To solve, let fx equal to square root x, in which x is 25.01. As x is equal to x0 plus delta x, therefore, x0 is 25 and delta x is 0.01. Differentiate the f, you should get 1 over 2 square root x. Then substitute x0 into the f and f prime, you should get 5 for the f x0 and 1 over 10 for the f prime x0. Substitute this value into the formula and simplify, you should get 5.001 as the final answer. You can also check the final answer using the calculator. By key in square root 25.01, the calculator will give you the answer 5.0009999. Let's proceed with 1b. To solve, let fx equal to 1 over square root x, in which x equal to 4.03. Here, x0 is equal to 4 and delta x is equal to 0.03. Next, differentiate the fx. You should get negative 1 over 2x to the power of negative 3 over 2. Then, substitute x0 equal to 4 into the f and also the f prime. You should get the answer 1 over 2 for fx0 and negative 1 over 16 for f prime x0. Substitute this value into the formula and simplify. You should get 0.498 as the final answer. Now refer to 1c. To solve, let fx equal to ln x in which x equal to 0.99. Here, x0 is 1 and delta x is negative 0.01. Differentiate the fx, you should get 1 over x as the answer. Substitute x0 equal to 1 into the f and f prime. You should get 0 for the f x0 and 1 for the f prime x0. Substitute this value into the formula and simplify. You should get negative 0.01 as the final answer. Refer to 1d. To solve, let fx equal to sin x and x equal to pi over 6 minus 0.1. Here, x0 is equal to pi over 6 and delta x equal to negative 0.1. Differentiate fx, you should get cos x as the answer. And substitute x0 equal to pi over 6 into f and also f prime. You should get 0.5 for f x0 and square root 3 over 2 for f prime x0. Substitute this value into the formula and simplify. You should get 0.413 as the final answer. Let's proceed with section 3.2 on related rates. Suppose we have two variables, x and y, which are both changing with time. A related rates problem is a problem in which we know one of the rate of change, let's say dx over dt, and we want to find the other rate, let's say dy over dt. If y is written in terms of x, that is y equal to fx, by using the chain rule, dy over dt can be obtained as dy over dx multiplied with dx over dt. Following are the general formula for the surface area and volume for some basic solid such as cube, cuboid, cone, cylinder, and sphere. This formula is useful to solve the related problems. These are the steps to solve the related rates problems. First, you need to understand the problem and represent the information given and to be found using mathematical symbol. Next, determine the suitable formula and differentiate. Then, apply the chain rule and substitute the given information. Finally, solve for the unknown rate. Now, let's refer to example 2. A is being pumped into a spherical balloon so that its volume increases at a rate of 100 cm3 per second. How fast is the radius of the balloon increasing when the diameter is 50 cm? To solve the problem, first of all, you need to understand the question. As given diameter is 50 cm, therefore the radius, which is denoted by r, is equal to 50 over 2, which is equal to 25 cm. As given, volume increase at a rate of 100 cm3 per second, this can be represented as dv over dt equal to 100 cm3 per second. The question asks to find dr over dt when the diameter is 50 cm. Take note that when you have the word increase, then the answer should be positive value. But if you have the word decrease, then the answer here should be a negative value. The formula for the volume of sphere is given by V equal to 4 over 3 pi r cubed. Differentiate dV over dr, the answer is 4 pi r squared. By using the chain rule, dV over dt is equal to dV over dr multiplied with dr over dt. Substitute the given information into this formula and simplify. You should get dr over dt equal to 100 over 4 pi r squared. Substitute the r with 25 and simplify. You should get the final answer 1 over 25 pi. Therefore, the radius of the balloon increasing at the rate of 1 over 25 pi centimeter per second. Let's proceed with example 3. A water tank has the shape of an inverted circular cone with base radius 2 meter and height 4 meter. If the water is being pumped into the tank at a rate of 2 meter cubed per minute, find the rate at which the water level is rising when the water is 3 meter deep. Here, the radius, which is denoted by r, is given by 2 meter, and the height, which is denoted by h, is 4 meter. Given as well the rate of the volume, which is denoted by dv over dt, is 2 meter cubed per minute. The question asks to find the rate of the height, which is dh over dt, when the height is 3 meter deep. To solve the problem, we need to use the formula for the volume of cone, which is V equal to 1 over 3 pi r square h. By proportional, r is equal to h over 2. Substitute this into the formula and simplify. You should get V equal to 1 over 12 pi h cubed. Differentiate the V with respect to h. The answer is 1 over 4 pi h squared. By using the chain rule, dv over dt is equal to dv over dh multiplied with dh over dt. Substitute the information into this formula and simplify. You should get dh over dt equal to 8 over 9 pi meter per minute. Therefore, the water level is rising at the rate of 8 over 9 pi meter per minute. Refer to example 4. A ladder 10 feet long rests against a vertical wall. If the bottom of the ladder slides away from the wall at a rate of 1 feet per second, how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet from the wall? Here, we denote the width as x and the height as y. Given that x is 6 feet and dx over dt is 1 feet per second, you need to find dy over dt when x is equal to 6 feet. From the formula of right-angled triangle, x squared plus y squared is equal to 10 squared. Differentiate this formula with respect to t. By using implicit differentiation, you should get 2x dx over dt plus 2y dy over dt equal to 0. Simplify this equation. You should get dy over dt is equal to negative x over y dx over dt. As x is 6, substitute this value into the formula. You should get y is 8. Replace the x and the y with 6 and 8 respectively and simplify. You should get dy over dt equal to negative 3 over 4. Therefore, the top of the ladder sliding down the wall at the rate of 3 over 4 feet per second. In order to check your understanding on this lesson, please do the following exercise. In the next lesson, you are going to learn on how to do analysis on functions.